Okay, today we're going to look at radical and rational equations. For radical equations, you want to make sure that you isolate the radical first. And you need to check for extraneous roots. So if I were doing number one, I would isolate the radical by subtracting 1. Then I would, to undo the cubic root, I would cube both sides. I would add 2. X is 29. Now, before I decide if 29 is an answer, I do have to do a check. And that's just so that, I figure out if it's an extraneous root or not. So the cubic root of 27 plus 1, yes, that does equal 4. So that's what I wanted to know, if this equals 4. So it checks. Now, you could also, you don't have to necessarily do a formal check. You could do a quick check just by plugging it in. With the next one, so we want to isolate the radical. So I want to minus x. Square both sides to get rid of the square root. Here, if you need to, you might need to go off to the side, write it out twice so you know to FOIL. When you FOIL, it'll be 1 minus 2x plus x squared. And then move everything to one side. X squared minus 3x plus 1. And then we're going to use quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops, sorry, I don't know where I wrote 0 equals, x equals. So x equals 3 plus or minus square root 9 minus 4 is 5. Now, what you're going to see when you check, and I'll actually show you this, maybe tomorrow when we do this live, or the next day that we do this live. If you do the check, you have to keep this an exact answer and plug it into the original. And what you're going to see is only 3 minus radical 5 over 2 works. The positive, the 3 plus radical 5 over 2 does not work. And again, I'll kind of show you how you do that another day, how you actually check it in the calculator. Now, the next one, there's a radical on both sides. You can't, move something and then have the radicals completely off of one side. So what we have to do is we have to square this. Square both sides, because if I square both sides, it's going to get rid of the radical on the left-hand side. The radical on the right-hand side is going to stay. We're going to have to FOIL first. 9 outers and inners, well, it's going to give me minus 3 radical 7 minus x, and then minus 3 radical 7 minus x, which is a minus 6 radical 7 minus x. And then last, minus minus is plus, and a radical 7 minus x times a radical 7 minus x is a 7 minus x without the radical. I'm going to need this room here, so I'm just going to erase this. So combining like terms, so let's see, we got 9 plus 7, so we get 16 minus x plus, minus the 6 radical 7 minus x equals x minus 2. Okay, so I can add x minus the 16, add the x minus the 16. I'm working on getting the radical alone, so this is 2x minus 18. Okay, now a lot of times, if people were looking to isolate the radical, they would say, oh, divide by -6. The only problem, you can do that, but if you divide by -6, if you think about it over here, 2 divided by a -6 is going to be a fraction. So because I don't want to get a fraction, what I'm going to do is I'm going to figure out what all of these could be divided by, which is 2. So I'm going to divide this whole side by 2, this side by 2. On the left, we would have x minus 9, right? Both of those get divided by 2, equals -3 radical 7 minus x. So you can divide these. Remember, you can divide numbers with numbers, radicals with radicals. So you don't divide the 2 with anything under the radical. 2 would have to be under the radical for you to be able to do that. Okay, so now I can go to squaring both sides to get rid of the square. Again, I didn't want to divide by 3 because I don't want to deal with fractions. That's why I'm not dividing by 3 there. So when I FOIL here, x squared minus 18x plus 81. -3 squared is 9, and then it's times square root of 7 minus x squared is 7 minus x. The reason it's times is because that's what -3 radical 7 minus x means. It means -3 times a radical 7 minus x. Distributing on the right, moving everything over to one side. X squared minus 9x plus 18. Factor. What multiplies to 18 adds to -9 is -6, -3. So when we solve that, x equals 6, x equals 3. Now, you would have to check, but both of those should work. So both of those are the answers. Now, with rational equations, you do not have to do a full check. All you have to check in a rational equation is that the denominator does not equal 0. So that's all you care about. The denominator can't be 0. So if I think about it, automatically I know here x can't be 0. If I looked at this one, I know x can't be 0, x can't be 3. So if I get those for answers, I'm going to reject it. Okay, so one way you solve a rational equation is you multiply through by the least common denominator, which would be a 6x squared. So everything gets multiplied by 6x squared. So there, that cancels. You have 1. Here, this is 3. This is x, so 3x. Here, those cancel. That's plus 1. 3x equals 0. Divide by 3. 0 divided by 3 is 0. Now, normally I would say that's my answer, but remember we said x can't be 0 because that would make the denominator of the fraction 0. So in this case, I would have to say no solution. Next one, if I multiply through by the least common denominator, that'd be x minus 3, x minus 3, x minus 3. So here, the x's cancel. We have an x minus 3 times 1, which is an x minus 3. Here, The x minus 3's cancel, so I have a negative 2x. And on the right, I'm going to take the 4x and distribute it. So 4 times x is 4x, and then I'm distributing it. 4x squared minus 12x. So this is a negative x minus 3. Just combining my like terms here and here. Moving everything over, add x, add 3, add x, add 3. 4x squared minus 11x plus 3. This one is actually not going to be factorable. You could, do where you play around with the outers and inners, but it will not be factorable. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And this will be radical 73 under the radical. We said you could only not have 0 or 3 from up here. So I'm going to keep both of those. Here we have to factor to see what our least common denominator is. So it looks like the least common denominator is x minus 2, x minus 1. X minus 2, x minus 1. Times this one by x minus 2, x minus 1. And technically we have to, also do that on the other side of the equal sign. But since it's times 0, it's just going to be 0. So here, those cancel. I have this times this. So I have to FOIL x squared plus x minus 2. So I automatically did my outers and inners. I did a plus 2x minus 1x. That's where I got a plus 1x. These cancel. Now here, be careful and distribute your negative 4. Negative 4x plus 8. If you don't distribute that negative 4, you're going to get that wrong unless you're really careful and put minus and then brackets. This denominator cancels with that, so it's plus 2, and then equals 0 times anything is 0. So we have x squared minus 3x plus 8. Right, negative 2, positive 2 cancel. So again, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we get our imaginary solutions. So you could say no real solutions, or you could just give those imaginary roots. The only thing we'd have to reject is if the answers was x equal 1 or x equal 2, right? Those would make our denominator 0. In the last one, if I factor x plus 4, so that is my common denominator, x plus 4 here, x plus 4 here, and an x plus 4 here. The 2x gets distributed to the x plus 4, so that's 2x squared plus 8x. These cancel, I have a minus 3x. These cancel, I have equals 12. 2x squared plus 5x. I'm going to move the 12 over, so minus 12 equals 0. I'm going to factor. 2 is prime, so just 2x and x. 12. I think I want the 3 here, the 4 here. Outers then would give me 8x, inners 3x, 5. To get 5, I would need plus 8 and minus 3. So remember, you want your lasts to give you the last. So negative 3 and 4 do give you negative 12. Your outers and inners should give you the middle. Okay, so this would be x equals 3/2. This would be x equal negative 4. Let's go up and see what x can't be. X can't be 0 or negative 4 in this case because of here, right? Either one of those would make the denominator 0. So we can't have the negative 4. We can have the 3/2. Okay, and that is it for day 2.